comprehensions. In the last video, we had a look at this code, where we have our friends list and our guests list. And in order to compare them both, we tried to turn them both into lowercase, and then pass them through sets, so that we could then print the intersection. And we did friends lower.intersection guests lower. However, we can just use set comprehensions instead of list comprehensions and then pass it through the set function. Just like we can do list comprehensions by using square brackets and then putting the thing we want to put into the new list for the iterating variable in the iterable, we can just do this. Instead of creating a new list first and then making a set out of it, we can just create a set straight away, and that is going to be faster and also a bit more readable. Let's do the same down here. Now, one of the problems we had in the last video with doing something like this is we weren't able to output the names in capitalized format. So we always had the lowercase names at the end because that's what we used to sort of compare them. But actually we can create a final set comprehension that does this for us. So what I've got here is a third set comprehension that puts the name turned into title case for the name in the intersection. Of course, it is easier if you take this out and put it into another variable, just like that. If we run this, you'll see that the output is now what we wanted. Though it is a little bit longer, it does have the extra benefit of removing any duplicate friends if there were any. So if somebody was in this list twice, for example, for some reason, either due to an error or maybe they RSVP'd twice or something like that, then this would get rid of that. However, it could also have the problem of removing duplicate elements. So if two people have the same name, you could end up with only one of those people showing up in these sets. Either way, I wanted to tell you that you can do set comprehensions, which is the same thing as a list comprehension, but using curly braces instead of square brackets, and you end up with a set at the end of it. Let's say you've got a list of friend names and how long ago since you last saw them, and you want to create a dictionary out of these two. What you can do is you can create something like a variable called long timers, and once again, using curly braces, just as we do with dictionaries, you can do friends I, times since seen I. And what this does is it accesses the ith element of the friends list. So for example, if I was 0, it would access friends 0, and that's Rolf, and it would associate with that this value here, which is times since seen 0, which would be 3. So you could end up with Rolf 3. Now, if you repeat this for every index, so 0, 1, 2, and 3, you'd end up with a dictionary of the elements which include all of these in these two lists. So you could do for I in range of the length of friends. And what this means is you are creating a new variable called I, and its values will range from 0, which is the start of the range function, up to the length of friends, which is 4. So it will go from 0 to 3 inclusive, and that would give you all of these. If we print this out and run it, you'll see what I mean. You get Rolf and 3, Bob and 7, Jen and 15, Anne and 11. One of the benefits of doing a list comprehension like this one is that if you were only interested in those people that you haven't seen for 5 days or more, you can of course put a conditional in here as we've seen. Something like that. So now you're only running this if the times since seen I, which would be the number that we're currently looking at, is greater than 5. So now you would only get Bob, Jen, and Anne. Running this, you'll see that that is correct. So dictionary comprehension, which is this, works in exactly the same way as set comprehension, in that you use the curly braces, but instead of putting a single value into the set comprehension, you put the key, the value, just as we did with dictionaries before. Dictionary comprehension is used much less than other types of comprehension, but sometimes it can be really handy. So I just wanted to show it to you, tell you that it's possible, and maybe you'll encounter it in the future. Thank you for joining me in this video. I hope you've learned. And that's because functions can not only perform actions which is what the calculate MPG function does here. It processes some data and then prints something out. They can also take some inputs and give us some outputs. What that allows us to do is to extract some of this code into a separate function so that they don't get too long. This calculate MPG function at the moment does a bit more than just calculate MPGs. It calculates MPGs, and then it also calculates the car name, and finally it prints it out. So there are a few things going on in this function, and that's usually something that tells you that you can have multiple functions instead of just one. A few things are going on, you can have one function for each thing. Let's make our calculate MPG function actually only calculate MPGs. What we'll do is after the calculation, we will just do return MPG. This is how you can return values, and what that means is whenever this function gets called, you can then assign that to a variable. For example, we could do something like this, and then the value of dividing the mileage by the fuel consumed, which is a float, will be assigned to the MPG variable via this return. We'll have 50.0, let's say as an example. We will return 50.0, and then we will assign 50.0 to MPG. Now, because that's happening, as soon as Python encounters a return statement, the function ends, and none of the other code evaluates. So what we've done here is we've made our calculate MPG function actually only calculate MPGs. Now we need another function to do the rest of the stuff. So I'll define a function called car name, and it will also take a car, and it will just calculate the name, and then it will return it. Finally, I'll make a function called print car info, which will take a car as well, and it will use these two functions to get the car name and to get the car's MPG. Finally, it will print it out. Notice that this function here does not have a return. So when we run this function, if we were to assign it to a variable like this variable would be equal to the special value none in Python. None just means no value. So all functions in Python return the value none by default, or you can of course just do return none if you want to make that explicit. None has a capital N, and again, it just means no value. What we've done here is we now have three functions. So I appreciate this is a little bit more complicated than it was before. We've got a function that calculates the miles per gallon, and it accepts a parameter, which should be some data, which has to be a dictionary, since we are accessing a dictionary's properties. And this car data has to contain a property mileage and a property fuel consumed. Then it's going to divide one by the other, and it's going to return that value. In the function print car info, which also takes a variable car as a parameter, which should be a dictionary with this structure, it then passes the value of that variable to the car name function and to the calculate MPG functions. Let's take the calculate MPG function as an example for this flow. We will receive the car information in the print car info function. Then it gets passed over the same value to the calculate MPG function, which uses the properties to calculate something. This return value then gets assigned back to the MPG variable inside print car info. So you can see how Python is jumping around. As soon as it encounters a function, it goes and runs the function code. If there's a return, then we can assign that to a variable. So running this function here is exactly the same as just copying this code and putting it there. However, because it has a name, such as car name, it's a little bit easier to read when you're looking at this function to understand what it does. Clearly, this function first gets the car name, or calculates it in some way, then it gets the car's MPG and it calculates it in some way, and finally prints some information out. And you don't necessarily have to go and look at these other functions as long as you believe that it calculates the name and the MPG correctly. But you can do if you want in order to understand how the name and the MPG are calculated. Notice that here at the end we have now got mpg equal print car info, but this print car info function does not return anything, or rather it returns none by default, so this is kinda useless, so we can just remove it. We can just call print car info, and that is going to run through this code here and print the information by using these other functions. I'll also say that it's good form in Python and generally recommended to leave 2 lines between each function definition so you can read through it a little bit quicker. Now this code is getting a little bit longer, but we can still run it and it will print out the same thing as before. Something that my students frequently do is a small mistake, which is to print this function here. If you say print of print car info, what you're doing is you are passing the result of calling print car info to the print function, which is then going to print this value out. The value that will get printed out is the return value of the function. But because this function returns none, what you'll see here is none printed out. So you still get all of the stuff from our previous functions, but now you get none in between each function as well. This is normally not what you want, so just don't print the result of calling that function. You can just call the function and let it print. If you wanted to print here, you can make this return. And then this function will now actually return this string, which then you can print out. If you don't print it out, you won't see anything output in the console because we haven't printed anything out. We've just got some values. If you want to show them, you have to print it out. So if you make the function return something, you can then use that value. If you make the function print, like we had earlier, then you don't have to use that value. Functions can return multiple times. And what that means is, let's say that you've got a divide function that takes 2 numbers and divides one by the other. But you want to make sure that you can't divide a number by 0 because that's illegal in mathematics. You can say if y is equal to 0, then you can return you try to divide by 0. But otherwise, we can return x divided by y. This works in exactly the same way that all if statements do, which is that if y is 0, then this code runs. But if y is not 0, then this code runs, and this one does not. Both of them will cause the termination of the function and the value to be given back to the caller, but only one of them will ever run in one function call. So you can have multiple return statements as long as they won't both try to run. So if you have this instead, this if statement will never run, because when this one runs, the function terminates. So having 2 return statements one after the other is not very useful because only the first one would ever run. So if you put them in an if statement, that's better. Either one will run, but both can run given the right circumstances. So if we print the divide of 10 and 2, you'll see that you get 5.0. But if you print the divide of 6 and 0, then you'll see the string gets printed out. You try to divide by 0. Once again, just to reiterate, if you call these functions but you don't print, nothing will get printed out because these functions calculate a value and give it back to the caller so that you can put it in a variable or do something with it, but you still have to print it out if you actually want to show it to the user. That's it for this video. I wanted to tell you about return values for functions because they really start allowing you to split out your code and move it from one place to another, putting it into functions so that you can reuse them in other parts of your code. As you learn more Python, you will increasingly put code into different functions so that you can use them in multiple places. Thanks for joining me. I hope you've learned something, and I'll see you. Lambda functions are used to get inputs, do a small amount of processing, and return outputs. Functions can do 2 things. They can perform an action, or they can return an output, or they can do both. For example, the print function is one that performs an action. It shows something to the user, but it doesn't really modify the data it receives and give you some new data. However, if you have a function such as this divide function, which takes 2 numbers and processes them and returns some output, this could be a good function to use in a Lambda function. The print function, though, would not be. That is because Lambda functions are used to take inputs and return outputs. If you wanted to rewrite this function, which at the moment is a normal function, into a lambda function, you can do this. Here we are creating the lambda function, and we are assigning it to the divide variable. If we do this, we no longer need this. The structure of the lambda function is as follows, and I appreciate it's a bit confusing because of its short nature and the amount of symbols involved. You've got the lambda keyword, then you've got a space, then you've got a list of parameters. So these are the inputs to the function. Here we've got two different inputs, one called x and one called y. Then after a colon, you have the return value of the function. So this function here takes two inputs and returns the division of the two. So again, it is identical to this function here, because this one also takes two inputs and returns their division. This one also returns their division, even though it doesn't have an explicit return statement. This is what lambda functions do. So, because it's got the divide name, you can still call it as you would any other function. Just call it with the brackets and put the values in there, and you get 5.0. Now, something interesting about lambda functions is what happens if you don't assign a variable to them. Well, Python will create this function and immediately destroy it. If there is no name associated with this function, Python realizes that you can't use this function anywhere else because you have no way of referring to it, so it will immediately destroy it. However, you can call this function like this. This is even more confusing, and I would almost never do this. But here you use brackets to tell Python that you want to run this code first. You create the function, and then now that you have this function, you can use the bracket notation to call it and pass in two values. Remember that this is identical to doing this if the divide function was already defined. But because it's not, you can do this, and that defines the function, and then the brackets signify that you want to call it and give it two values. Now notice that if you run this, the function does evaluate, but nothing gets printed out, so you have to chuck this into a print statement, which makes it even more confusing. Now you get 5.0 back, but this code is pretty crap code, because there are a lot of brackets, symbols, things going on in a single line that frankly don't have to be in one line. You could define this in another line and make this a bit more readable, make it a bit clearer what's going on. So what is the purpose of lambda functions? Lambda functions can, at times, provide more simplicity to code. However, just as you've seen there, they can also at times make it more complicated. So you do have to be careful with lambda functions when you're using them. Let's look at an example. Here we've got some code where we define a function called average that takes in any arbitrary sequence and returns the sum of its elements divided by the length of the sequence. So, for example, if we iterate over our list of students, we can then call the average function with each student's grades. And what that is going to do is it's going to take these grades, and then these, and then these, and then these, and it's going to calculate the average of each, and it's going to print it out. Pause the video for a moment if you need a bit more time to look at this code and thoroughly understand it. Just as we have defined our average function here, we could make this into a lambda function if we think that's going to make things simpler. I think that certainly it's not going to make them more complicated, so maybe you could do something like this. This behaves in exactly the same way because this is a function that still takes in a parameter and then adds it all together and divides it by its length. However, it's fairly uncommon in Python to use lambda functions in this way. That's because when you have a function that's sitting on its own and you're assigning it to a variable, you might as well just define a normal function. It makes it a little bit more readable. So while you can do this, and this is one of those use cases where you might use a lambda function, there are better scenarios for using lambda functions. So we're going to look at some of those in the next video. For now, though, I just wanted to tell you about the Lambda function structure and syntax, which is the Lambda keyword followed by any parameters, then the colon, and then the return value of the function. And remember, Lambda functions are used for getting inputs and returning outputs, and they're not used for performing actions, such as what the print function does. Thanks for joining me in this video. In Python, functions are first-class citizens, and that means that just like strings and integers and anything else really, we can assign functions to variables and we can pass them in as arguments to other functions. We're going to learn more about doing just that in a later video in this course, but for now let's focus on assigning them to variables and using them as values in lists and things like that, and why that can be useful. Let's get started. Let's say that we've got a greet function that prints hello. You know that, of course, we can call the greet function and that's going to run it. And the calling of the function happens when you use the brackets after the function name. So what happens if you just use the function name? Well, we know that that's not going to run the function, so we get no output. But this is still valid Python syntax. What this tells Python is that we're talking about this function here, about the value of the function itself. We don't want to run it, but we are talking about it. We are referring to it. When we have a value, just as a number, a string, or anything else, including a function, we can assign it to a variable. We can say this name here, this hello name, is now a name for the value that this references, and that is the function. So now after this line, hello and greet are the same value. And therefore, that means that we can run the hello function. And you can see here that that's going to print out hello. This is what I mean when I say that a function is a first-class citizen. You can assign it to variables, and as we learn, you can put it inside lists or dictionaries or anything else. Like I mentioned earlier, you can also pass functions to other functions as arguments, but we won't look at that until much later on in the course. Anyway, this is not a particularly useful example, so let's move on to a more useful one. Imagine that I want to create a function that calculates the average of a sequence. So for example, def average like that takes in a sequence and then returns the sum of sequence divided by the length of the sequence. Pretty normal function, we've seen this before, so we can recreate this as a lambda function just for shortness, and we covered how to do this earlier on. This would be lambda sec is a sum of that divided by that. So this is the same stuff, just this one is as a lambda function. The reason why I'm making this a lambda function and not a normal function is just because it's a little bit shorter, and these other functions that we're going to create here are also good lambda functions. Just like that. So now we've got three functions, average, total, and top. The average one calculates the average, total calculates the sum, and top calculates the maximum value of a sequence. Now, let's say we've got a list of students that I'm going to paste in here. We've got a list of dictionaries, and each student has a bunch of grades associated with them, and that is a tuple of numbers. So that's, let's say, the grades that they got in an exam. Let's use these functions now to operate on these grades. How we do it is we'd say for student in students, we're going to get the name as student name and the grades as student grades, just like that. Then we're going to print out the student name. And finally, we're going to ask the user what they want to do. Do they want to calculate the average of their grades, the total of their grades, or the top value that they got? So we'll say that the operation is input, and we'll ask them to enter either average, total, or top. Sorry that this has gone into two lines there. I'm just going to move that a bit. There we go. So now we're going to ask for each student what the user wants to do with their grades. Now comes the simple part which is to write an if statement that deals with this user input. We know how to do this. We've done this a lot of times before. If the operation is equal to average, then we will print the average of grades. So nothing new here. We're saying that if the user entered the word average exactly, then we're going to print the result of calling the AVG function, which was defined up here, on the student grades, which are each tuple for each student. So let's just run this at this point. And of course, if we enter average, then we get the average grade for Rolf. If we enter average again, then we get the average grade for Bob. If we enter something else, like total, we get nothing because we haven't coded that part of the if statement yet. Let me stop this here. If we completed the other operations, they would look like this. If the operation is total, then we print out the total. Otherwise, if it's top, we print out the top. Nothing new there. So how can we make this code a bit better, a bit shorter, a bit simpler? The first thing that we have to realize is that we're asking the user to select what they want to do using code language, if you will. And so what we're doing here is we're giving the user a few specific options, and then we're selecting one of those options that matches something in our code, a function that we want to run. Therefore, if we can say select whatever the user entered and run the function associated with that, that's going to make our code a bit simpler. So how do we create associations in Python? We use dictionaries. So we'll create an operations dictionary and we'll associate each thing that the user can enter with one of the functions that we defined above. Just like that. So now we've got an operations dictionary that maps user inputs to functions. And once we have that, all we have to do is get the operation function by saying operations operation. So that is going to go into the operations dictionary and get us the key that matches the user's input. So if they entered average, then that's going to get us AVG, the AVG function. Not the result of running the AVG function, but the AVG function itself. And so on with the others. Therefore, once we have the operation function, we can call it with the student grades. So now if we run that, you'll see that we can enter, for example, top, and we get 100, which is the top grade for Rolf. For Bob, we can enter average, and we get 76, which is their average. And if we enter something completely random, like something else, we get an error. Now, this is the compromise that we're making when we use a dictionary instead of an if statement. With a dictionary, we're going to get an error when we try to access a key that doesn't exist, but with an if statement, we would not get an error there. What we can do is we can use error handling to catch the error and print a nice error message instead. But we're going to learn how to do that later on in this course. Something else to remember is that we can make this code even shorter if we want, and if we're comfortable with that, by inlining the Lambda functions into this dictionary. I'm not entirely sure how I feel about this. I think it's getting a bit complicated, but you can do it if you want. With these functions that are relatively small and simple, I think it's probably okay, but if it gets more complicated, if your functions are doing more things, you'll definitely want to separate them out and use the operations dictionary to sort of compile them into one readable block of things that a user can do in your code. Something else that I wanted to mention at this point is that we've got here sort of like a proxy function, something that we define as a function that just calls another function with the same arguments. So you can see that our function here is just receiving an argument, passing it to the sum function and calling that. So instead of doing that, we could just use the sum function directly. Why? Because now when we access the sum function through this operations dictionary and we call it, we'll essentially be calling sum of grades, which is what we were doing before, but just we've removed one layer of our own functions that wasn't really doing anything. So that's just the small optimization thing you can do there. You can use sum and max directly instead of coding your own Lambda functions. Of course, we can't do that for this one because it's not just passing the argument to another function, it's actually using two functions there, so we can't do that in there, but we can simplify those two. Now, inlining the functions makes more sense because we're just using some built-ins, we're not really adding any complexity. Alright, I hope this makes sense. I know it's a little bit tricky to